All right, section 8-5, the law of sines. All right, so let's draw a line segment from each angle to the angle opposite. So angle A, the side opposite is side A. Angle B, the side opposite is side B. And an angle C, the side opposite is C. A ratio is a comparison of two quantities by division. Okay, so sine. All right. In the right triangle, the sine is the ratio of the side opposite of a given acute angle to the hypotenuse. So if you know the measure of an acute angle of a right triangle and the length of the opposite side, you can use the sine ratio to find the length of the hypotenuse. So a triangle has a given acute angle, find its sine ratio, and it's going to be opposite over hypotenuse. A right triangle has one acute measure, 36.9 degrees. The length of the side adjacent to it is 4 units, the side opposite is 3, and the length of the hypotenuse. What would be the sine of this ratio? Well, it would be 3 to 5, the opposite over the hypotenuse. All right, now, what we can do is extend this knowledge from right triangles and apply something to all right triangles. So for any triangle, ABC, let the lengths of the sides opposite angles ABC be A, B, C, respectively. Then the law of sines relates each angle to the length of its opposite side, and we have an extended ratio. So the sine of A over A equals the sine of B over B equals the sine of C over C. So if I know two angles and one side of a triangle, can we find all missing measures? The answer to this is yes. So all I need are two angles and one side. Okay. So basically what happens here is since I know two angles, I can find the third by subtracting from 180. Then use law of sines to find missing side lengths. Okay. So let's label this. In triangle ABC, we know the measure of angle A is 48, the measure of angle B is 93, and AC is 15. What is AB to the nearest 10th? So the measure of angle C would be 180 degrees plus, equals 48 degrees plus 93 degrees plus 39 degrees. So let's label that in the triangle. So the side lengths A, B, and C, which side length is AB? C. So we're going to use this ratio first. Okay. I want to pick the ratio or the proportion, the equation, in which I have 3 of the 4 parts. Okay, so replace the information. I know that the sine of 39 degrees over C equals the sine of 93 degrees over 15. What I'm going to do is multiply. So a sine of 39 degrees is 0.6293 times 15 over the sine of 93 degrees, which is 0.9986. Dividing, you get 9.453. So the length is approximately 9.5 units long. Okay. So here's some pieces of information. Label the triangle from the problem with the sides KLM. Bingo, done. Okay. So 13, use a letter that represents the following. So we're going to say the sine of L over L equals the sine of K over K. So setting this up, we have the sine of 105 over 14 equals the sine of K over 9. So we have the sine of K is approximately equal to 0.9659 times 9 over 14, which is approximately equal to 0.6210. 0.6210. So we're going to take the inverse of both sides to solve for the angle, and we get the angle is approximately 38.4 degrees. Okay. All right, so the right fielder fields a softball between first base and second base as shown in the figure. If the right fielder throws a ball to second base, how far side does she throw? All All right, so underline the correct word for each sentence. In this problem, the solution is a side. To find the solution, I need to first find the missing angle. Okay? So we do that by subtracting from 180. You get 72 degrees. We know this is going to be side C then. This is going to be side A, and this is going to be side B. So we're going to use the equation. Sine of 72 degrees over 60 equals the sine of 40 degrees over C. Plugging that stuff in, we get the sine of 72 degrees over 60 equals the sine of 40 degrees over C. So sine of 72 degrees is 0.9511 over 60 equals sine of 40, which is 0.6428 over C. We're going to multiply or cross multiply. Using the calculator, we get C is approximately equal to 40.6. So Kimmy throws the ball about 40.6 feet. All right, let's review, see if we understand what's going on here. So what do AAS, ASA, SSA stand for? So AAS stands for angle, angle, side. ASA stands for angle, side, angle. SSA stands for side, side, angle. Okay? All right, so to use the law of sines, you need two angles and one side, or two sides and one angle. All right, so your friend uses the law of sines to write this to find Q. What's the error? The side length opposite angle R is 4, not 3. And that's the end of this section.